Alright, given this function f of x equals x to the fourth plus 3x squared, determine if it is even, odd, or neither. To do that algebraically, what are we putting in there? Negative x for every x value. So, the screen is frozen. It is now defrosted. Kind of. So, to determine algebraically, you're going to sub in negative x for every x value. So basically we're going to put in negative x for every single x value, right? We've been doing that this past week, so let's do that. F of negative x equals negative x to the fourth power plus 3 times negative x. And then this means negative x times negative x times negative x times negative x. That's just going to be x to the fourth. Remember here, I'm not going to do multiplication, I'm going to do exponents. So this is negative x times negative x, which is just x squared, and x squared times 3 is just 3x squared. If you recognize that it is equal to the original says every time you see f of x, you can write x to the fourth plus 3x squared. If we see x to the fourth plus 3x squared, it is f of x. I see x to the fourth plus 3x squared, therefore I can write f of x. Which basically means it is equal to the original. The answer is even. Raise your hand if you got that. Graphically, you can punch that into your graphing calculator. But let me skip down and do this skill, because there's going to be some problems where I'm not going to use the calculator, is if we made a sketch. So what kind of sketch can we make? So I'm gonna come back to this one. That'll be our final answer. But the leading coefficient, try to highlight that. That is if it's a plus or a minus here. So our leading coefficient, is it positive or negative, class? Positive. Is it going to change those arrows? No, it's not going to change the arrows. And the question is, what arrows are you talking about, Mr. Ng? Well, that is the idea if it's an even or odd degree. Okay, do you see the difference between the two questions? This one does have odd and even, but this one also has odd and even, but this one has degree. So we look at the highest degree or highest exponent, which is a 4. What does that mean? Well, it is an even degree, and the easiest one that we know is 2. And that has points up, ends up, right? So if I already know that that's going to be like my graph, I think the graph's going to look something like this. Okay, starts up, ends up. X to the second, x to the fourth are both evens. Okay? They're not going to flip. They would flip if this was a negative. Okay, let's look at it graphically now. My shortcut, if you're using Desmos, if I allow you to, plus 3x squared. Graph it. Okay, just look at my graph now. I'm going to change my zoom. X minimum, maybe -1. Y scale, -5, +5. And I want to change my X max to 40 and count by 5s. Boom. Try that again. That's not what I wanted. -5 to +5, count by 1s. Y minimum, -5, 40, count by 5s. Boom. Okay, so it pretty much looks like a parabola almost, right? Let me try one more time. Okay. Y max, let's go 200. Let's count by 20s. Oh, it still looks, the main idea is that it's pointing up and ends up. Okay? So that's what ours look like. Okay, let's talk about our end behavior now. Class, it'll always read in this red box. One of those will be One's positive and one is negative, always. This mean goes in which direction? To the right. And our graph finishes what? Up or down? Up. Look for the arrows. So how do you write up? Positive infinity. F of x. The y values are going up. As you go which direction? As x approaches negative infinity, which is what? Right to left. So going towards the left. The roller coaster finishes what? Up. Which is what? Positive infinity. Remember, those are the same. Your arrows are pointing in the same direction. So this was our quick warm-up review.